h cap E1 plus v cap E2 exponential j delta into exponential minus j omega t. Delta is the phase difference between the horizontal component and vertical component, and E1 and E2 are normalized or horizontal component and vertical component. Now from this we can write this as, if I expand this, we can write this as h cap E1 into real part of h cap E1 into exponential minus j omega t. Real part of E1 into exponential minus j omega t is E1 into cos omega t. So the first part will be h cap E1 cos omega t plus v cap into real part of E2 into exponential j delta into exponential minus j omega t. That is equal to exponential j minus omega t plus delta. Real part of it is cos minus omega t plus delta. So this will be v cap into E2 into cos minus omega t plus delta. So we have two components, one is horizontal component, one is vertical component. So for the horizontal component we can write it as pH is the horizontal component of the vector, polarization vector, and PV as the vertical component of the polarization vector. So that pH is equal to E1 cos omega t and PV is equal to E2 cos minus omega t plus delta. So pH is equal to E1 cos omega t. Now from this pH is equal to E1 cos omega t, we can write cos omega t is equal to pH by E1. If cos omega t is equal to pH by E1, then we know sin omega t or sin theta we know is equal to root over of 1 minus cos square theta. Use that. So sin omega t will be root over of 1 minus cos square omega t. So 1 minus cos square omega t is pH by E1 whole square. So pH by 1 minus pH square by E1 square root over is sin omega t. So now we have found out what is sin omega t. Now let us write what is PV. PV is equal to E2 cos of minus omega t plus delta. As you know, cos A minus B will be of the form cos A cos B plus sin A sin B. So use that formula. So that gives us PV is equal to E2 into cos omega t into cos delta plus sin omega t into sin delta. Now we know what will be cos omega t into cos delta plus sin omega t into sin delta. That part will be equal to PV by E2. Because from the above equation, PV is equal to E2 into cos omega t cos delta plus sin omega t sin delta. Divide both the sides by E2, that gives us cos omega t cos delta plus sin omega t sin delta is equal to PV by E2. Let us rewrite that equation. Cos omega t we know pH by E1. So for cos omega t let us write pH by E1. So pH by E1 into cos delta, that is the first term. Then look at the second term, it has sin omega t. Sin omega t is equal to square root of 1 minus pH square by E1 square. So write that. So plus square root of 1 minus pH square by E1 square, that into sin delta, that will be PV by E2. Now what we will do is take the square root term into one side, all other terms into one other side. So if we do that, then this equation becomes pH by E1 cos delta minus PV by E2, that we have taken from the right hand side to the left hand side. So in the right hand side it was PV by E2, on the left hand side it becomes minus PV by E2. So that will be equal to square root term was plus on the left hand side, that we take to the right hand side. So that will be equal to minus square root of 1 minus pH square by E1 square into sin delta. Now square both these terms. If we square both the terms, then the left hand side becomes pH by E1 cos delta minus PV by E2 whole square is equal to in the right hand side square root, if you square it, it becomes the square root goes out, so that term becomes 1 minus ph by e1 square. Then that into sine delta square is sine square delta. So this is how we rewrite this. Now let us expand this. If we expand this, the left hand side gives us ph by e1 square into cos square delta plus pv by e2 square minus 2 times ph by e1 into pv by e2 into cos delta, that is equal to sine square delta minus ph by e1 square into sine square delta on the right hand side. So we have expanded that. Now from the right hand side, let us take the sine square delta to the left hand side and put all ph by e1 term together and all pv by e2 term together. So ph by e1 square term together and pv by e2 square term together. So that gives us ph by e1 square whole into sine square delta, which has come from the left hand side to the from the right hand side to the left hand side. So that gives us sine square delta plus cos square delta, that is from the left hand side. So that is there. Then minus 2 times ph by e1 into pv by e2 into cos delta. Then plus pv square by e2 square. That will be equal to, on the right hand side we are left with only sine square delta. Sine square delta plus cos square delta is equal to 1. So if we use that, that gives us ph by e1 whole square minus 2 times ph by e1 into pv by e2 cos delta plus pv by e2 square is equal to sine square delta. This is a famous equation. This is a general equation for an ellipse. So this describes an ellipse. Since it describes an ellipse, the vector component in the form of vector component, the tip of the, in general, the tip of the vector polarization vector will describe an ellipse. We will see the special cases, but in general, the tip of the vector or tip of the polarization vector will describe an ellipse, which will be defined in terms of its components and the electric field components, E1, E2 normalized electric field components, as well as the components, vertical and horizontal components of the polarization vector. Now, on general equation of an ellipse, if you look at general equation of an ellipse, ellipse has a semi-major axis, which is A. In general, you might have studied it. It is called to A. A is the semi-major axis of an ellipse. We are seeing an ellipse here. So it has semi-major axis A. A semi-minor axis is B. A and B are orthogonal to each other. A is tilted with the x-axis. In general, A will be tilted with the x-axis. Particular cases, A is aligned with x-axis, but A is tilted with the x-axis, making an angle tau. Therefore, tau is called the tilt angle of the ellipse. So, in general, if we look at an ellipse, when we analyze it in coordinate geometry, ellipse has a semi-major axis A, semi-minor axis B, and a tilt angle tau, which is the angle between the semi-major axis and the x-axis. Now let us consider some special cases. We started with the general equation of the ellipse, which is ph by e1 whole square minus 2 ph by e1 into pv by e2 cos delta plus pv by e2 square is equal to sine square delta. We will consider a special case. First special case is the case of linear polarization. For this, let us take delta is equal to 0, which means the phase difference between the two components is equal to 0. Between the two component, vertical component and horizontal component of the electric field is equal to 0, or the vertical component and the horizontal component of the electric field are in phase. So delta is equal to 0 implies that if we put delta is equal to 0, sine delta is equal to 0, so sine square delta is equal to 0. So right hand side becomes 0. Cos delta is equal to 1. So the left hand side now becomes ph by e1 square uh, minus 2ph by E1 into Pv by E2 plus Pv by E2 square is equal to 0. Left hand side is actually the whole square of pH by E1 minus Pv by E2. So pH by E1 minus Pv by E2 whole square is equal to 0, which means we have got Pv by E2 is equal to pH by E1. So Pv by E2 is equal to pH by E1. That gives us Pv is equal to E2 by E1 into pH. Now look at this. This is of the form y is equal to mx. Y is a variable or dependent variable. X is the independent variable. M is the slope. This is of the same form. Y is equal to Pv here. pH is the independent variable, which is equivalent to x. And E2 by E1 is M. So if you look at this, y is equal to mx represents a straight line passing through the origin. So Pv is equal to E2 by E1 into pH represents a straight line. Straight line is a linear. This is a linear equation. So and this is an equation of a straight line with slope E2 by E1. When E2 is equal to 0, then this straight line is horizontally linearly polarized. When E2 is equal to 0, what will happen? Pv is equal to 0. When E2 is equal to 0, Pv is equal to 0. So therefore, the slope is equal to 0. P2 is equal to 0 gives us slope is equal to 0. Slope is equal to 0 means P is oriented along the horizontal axis. Therefore, it is called horizontal or parallel linear polarization. When E1 is equal to 0, then the slope is infinity. Slope is infinity means the line is vertical. It is oriented along the vertical axis, or it is oriented parallel to the vertical axis, or it is perpendicular to the horizontal axis. Therefore, E1 is equal to 0 gives us a vertical or the perpendicular linear polarization. So we have two types of linear polarization. One is horizontal linear polarization, one is vertical linear polarization. So we got two types of linear polarization. So we discussed about linear polarization of electromagnetic wave, plane electromagnetic wave. Now let us come to the second special case, which is elliptical polarization. We start with the general equation, which is pH by E1 square minus 2 pH by E1 into Pv by E2 cos delta plus Pv by E2 square is equal to sine square delta. This is the general equation, and this is the general equation of an ellipse. So this describes us an ellipse. Now let us consider delta is equal to plus minus pi by 2. We are considering special elliptical polarization. So delta is equal to either plus pi by 2 or minus pi by 2. So delta is equal to plus minus pi by 2. When delta is equal to plus minus pi by 2, sine delta is equal to 1. So right hand side will be sine square delta, which is equal to 1. Cos delta will be equal to 0. Therefore, this equation now becomes pH by E1 square plus Pv by E2 square is equal to 1. This is a general equation of an ellipse, which is x square by a plus y square by b is equal to 1. That is the general equation of an ellipse, where the semi-major axis or the semi-minor axis is oriented along the x-axis or the horizontal axis, and semi-minor axis or semi-major axis is oriented along the vertical or the y-axis. So this is the equation of an ellipse where the tilt angle is equal to 0. So now the tilt angle is equal to 0, that is one case. Then the case this is the equation of an ellipse where this one is E1 is not equal to E2. E1 is equal to E2 will give us some other consideration. Now look at this. When delta is equal to plus pi by 2, what happens? When delta is equal to minus pi by 2, what will happen? So that we'll find out later exactly what happens. That we'll find out later. But for the time being, let us look at two conditions. That on the ellipse, the tip of the tip of the polarization vector describes an ellipse. So the tip is moving. When the tip moves, it can move in the clockwise direction or it can move in the anti-clockwise direction. Depending on which direction it is moving, whether it is moving in the clockwise direction or in the anti-clockwise direction, we define the sense of polarization as left-handed elliptical polarization or right-handed elliptical polarization. We call it to be left-handed elliptical polarization when the wave is receding, which means it is moving away from us. We are looking at the wave. Wave is going away from us and the tip is moving in the anti-clockwise direction. So in that case, we call it left-hand elliptical polarization. Now, on the other hand, when the wave is moving away from us, but the tip is moving in the clockwise direction, we call it right-hand elliptical polarization. How do you know that? How do you define this? Or why we define this in such manner is very simple. Put your thumb out and curl your fingers. Now, when you put your thumb out, curl your fingers, and put your thumb away from yourself, look at the direction in which your fingers are curled. When the thumb is away from you, you have elongated or extended your thumb away from you. That indicates the direction of the propagation of the electromagnetic wave. It is going away from you. In that case, the fingers are for the right hand side. For your right hand, the fingers are curled in a clockwise direction. So therefore, that is called right hand elliptical polarization because it is related to right hand. With respect to right hand, we are defining the sense. Therefore, it is called right hand elliptical polarization. Similarly, left hand elliptical polarization is put your thumb, take your left hand, extend your thumb and curl your fingers. So when thumb is extended away from you, the curling is in the anti-clockwise direction. That is why it is called left-handed elliptical polarization. So the sense of polarization is defined in this manner. Then we will see whether when delta is equal to pi by 2, whether we will get an RHEP, or when delta is equal to minus pi by 2, we will get RHEP. That we will see later. But for the time being, we see that we get elliptical polarization under the special condition that delta or the phase difference between the two components is plus minus pi by 2. Under that condition, we get the ellipse, special ellipse, which is oriented with tilt angle 0. Now we'll come to the third case, third special case, which is called the circular polarization. In this case, E1 is equal to E2, that let us say E, that is equal to E, and delta is equal to plus minus pi by 2. If that happens, then the equation now becomes pH square by E square, because E1 is equal to E. So pH square by E square plus PB square by E square is equal to E square, from which we will get pH square plus PB square is equal to E square. Now pH square plus PB square is equal to E square is of the form x square plus y square is equal to r square, which is the equation of a circle. So this, under this condition, when delta is equal to plus minus pi by 2, or the phase difference between the two components, horizontal and vertical components, is pi by 2, and the amplitude of the horizontal and vertical components are same. E1 is equal to E2, which is equal to E. Under this special condition, we can get a circular polarization. That means the tip of the polarization vector describes a circle. Now, when it describes a circle, it can again be rotating either in the clockwise direction or in the anti-clockwise direction, as in the case of ellipse. Therefore, we can get RHCP or LHCP. RHCP is right hand circular polarization. R is right, H is hand, C is circular, P is polarization. So RHCP or LHCP. Similarly, it is left hand circular polarization. And the definition is as in the previous case. Now, now let us look at it in a little bit detailed manner. The sense of polarization that I told you, left-hand circular polarization and right-hand circular polarization. Let us consider this sense in a little bit detailed manner. What we have is, now let us take delta is equal to pi by 2. We said that delta is equal to plus minus pi by 2 can give us circular polarization or elliptical polarization. Let us consider the circular polarization. So I will take delta is equal to pi by 2 case. If delta is equal to pi by 2, then cos omega t plus delta, or cos minus omega t plus delta, that is equal to minus sin omega t. So if that part is minus sin omega t, then the polarization vector has two components. One component is ph, which is equal to e cos omega t. Other component is pb, which is e cosine of minus omega t plus delta. Sorry, cosine of omega t minus omega t plus delta, right? So if we put that, that gives us the PV is equal to minus E into sine omega t. Now let us draw a circle. Start with omega t is equal to 0, because we are the tip of the P vector is describing the locus with time. So omega t is equal to 0. In when omega t is equal to 0, sin omega t is equal to 0. So vertical component is 0. We have only but horizontal component. So it will be along the horizontal axis. So look at this circle. Within the circle, we have got a blue line which is from the center to the perimeter. You can see a vector or a arrow from the center to the perimeter. A blue line on the superimposed on the orange line. So that gives us, when omega t is equal to 0, what is the polarization vector? That is the polarization vector. Then we look at omega t is equal to r pi. Instead of 0, it is at omega t is equal to r pi. If we take omega t is equal to r pi, so any other instant after t is equal to 0, t is greater than 0, which is omega t is equal to r pi, indicates that t is greater than 0, so omega t is not equal to 0. Omega t is equal to r into pi. R is a rational number, so some amount into pi. So if that occurs, then we will have a horizontal component and a vertical component which is downward. Why? It is downward because it is minus sin omega t. So minus is in the negative vertical direction. So not in the upward direction, in the downward direction. Vertical, but in the downward direction. Because minus sin omega t, so that will have a component which is downward, and cos omega t will have a component which is towards the right hand side, from the left to right, and the vertical component is from top to down. Therefore, we will get the second line. When omega t is not equal to 0, we will get the second line. So that is shown in the circle. So that will be downward. So if you look at from omega t is equal to 0 to omega t is equal to r pi, we have moved on the circle in an clockwise direction. So delta is equal to pi by 2. We are moving in a clockwise direction. Then omega t is equal to pi by 2 will reach the vertical downward direction, because pi by 2 cos omega t will be 0, or cos pi by 2 will be 0. We will have only the vertical component, and vertical component is minus sin omega t. So it will be in the downward direction. So that way, as you keep on increasing omega t from 0 to pi, you will complete the circle in an anti-clockwise direction. So on delta is equal to pi by 2, we move in anti-clockwise direction. If it is anti-clockwise direction, then we move in the clockwise direction. If it is in the clockwise direction, then it is the right-hand circular polarization. So delta is equal to pi by 2 gives the right-hand polarization sense. Then delta is equal to minus pi by 2, that will give us cos minus omega t plus delta is equal to sin omega t. When delta is equal to minus pi by 2, this will give us sin omega t. If it gives us sin omega t, then at omega t is equal to 0, it will be from the left to right. The arrow will be from the left to right. Draw it from the center of the circle to the perimeter of the circle from left to right. Then at omega t is equal to r pi, so any other value, it will have two components. One is the horizontal component, which is from the left to right. Other is the vertical component, because sin omega t is positive. We have a vertical component. It will be from bottom to top. Therefore, it will move in the upward direction. So it will move in the anti-clockwise direction. Then at omega t is equal to pi by 2, we will have only the vertical component. There will be no horizontal component. When pi by 2, sin pi by 2 is equal to 1, but cos pi by 2 is equal to 0. So we have only the vertical component. That it will complete the complete cycle. So delta is equal to minus pi by 2. The rotation is in the anti-clockwise direction. Therefore, sense of polarization is left-handed. So delta is equal to plus pi by 2 gives us sense of polarization is right-handed. Delta is equal to minus pi by 2 gives us sense of polarization which is left-handed. I hope you have understood up to this point. Here we will take a break and then we will come back after 5 minutes. कॉजेट बंद कर देता